All right. Welcome back to Yay Math. This year we're not going to be doing any more jokes and no more fun stuff. It's all going to be about math. All right. Psych! Yeah! Oh, okay, that's a lot. I have a sword, by the way. I didn't tell you guys that. Dude. Alright, so I'm going to magically make this disappear. Alright? Cue music. I'm going to make it disappear. Alright, hit stop capture. Not enough, not enough. Okay, I got to try again. There you go. Oh, whoa, look at that. Wow, magical erasing of the board. Okay, it's gone. I'm not going to put it away. Not really a knight. Okay, so welcome back to Yay Math. Yay Math?
Yay Math!
Oh, God. Never gets old. Love it. They heard. They heard. Yeah, we're back, baby. We're back. Blow that shofar. Okay. Today we're doing properties of real numbers. Okay, so let's talk. Are they still laughing? Okay, they're not. No, it's in my head. Delusion. Blow it, blow it, blow it. Saxophone. All right. So let's talk about numbers. Go. In the back, it's like. Everyone, laugh at him. Just kidding. We're not going to really laugh at you. Okay, so let's talk about a couple numbers. One type of number is called natural numbers. Anyone can raise their hand and say what type of numbers are natural numbers? Good. Okay, we've got one person, yeah.
Is that a whole number?
It's kind of like a whole number. There's also something called a whole number. We'll get into that. Natural numbers basically start at 1, 1, 2, 3, and on and on and on. So the number 5 is a natural number. Right. Is 0 a natural number?
No.
No. Good. So in this little box, you could put like here, in the world of numbers, right? This is the world of numbers, by the way. It's a box made with marker. This is the area for natural numbers. All right. The next is called whole numbers. Okay. Whole numbers are just like natural numbers, except it's 0, 1, 2, 3, and so on and so on. The crown's going to be in the way. It's like, write it down. Okay, so that's whole numbers. So basically, this is what we're going to do. This is why we have this thing, whole numbers. So let me ask you a question. If a number is natural, is it whole?
Yes.
Yeah.
Yes.
Except 0.
Good. If a number is natural, it's always whole.
Except 0.
But 0 is not natural.
Right, so except 0.
Right. Whole numbers are natural numbers except 0. Question. Nice and loud. Nice and
Are
loud.
negative numbers whole numbers
Nope.
or natural numbers?
No.
Okay.
Good question. Not negative numbers. The next numbers in this list we're adding. Integers. Integers are the negatives included. So we have
All negatives?
all negatives, but on whole increments. So no 3.5, but like -3 would be okay.
So
So only after 0? Like whole negative
It's like all the negatives, all through 0, and all the positives, no decimals, no fractions.
So
pretty much everything but decimals.
All the positives too. Yeah, I'm getting into that. Here we go. 1, 2, 3, and so on. Yeah, pretty much all whole numbers that are not decimals, positive or negative, including 0. So the symbol we're going to do for integers, we'll make it a Z. That's usually what they do. I don't buy into stuff like symbols. Don't worry about it. Just know what an integer is, please. Okay. Then we have two possibilities. Rational and irrational. Yeah, right? Good guess. Okay, so rational is actually a type of number. It's not the way your mom acts when she's throwing a fit. Oh, that would be irrational. Rational is definitely the way I act in the world, except when I'm really upset, and then I just kind of put on my crown and cry at the gas station. Are you laughing because you do that too?
Yeah.
Okay, good. I'm not I am wearing a crown. I didn't even realize it. It's very comfortable. It's foam. And for the viewers at home, yes, I do have an afro. Okay. Headache. Okay. So rational, irrational type of numbers. Rational numbers are all your, like, fractions, you can say. So like 1/2, all fractions. All decimals that are that end at a certain point. So let's say 0.45. Okay.
Wait,
Repeat.
it has to be in the hundred spot?
No, any decimal. So far, I'm going to talk a little about it. I'm going to talk about it. So far, it's decimals and fractions. Yes.
Could a ratio be a rational number?
A ratio, it's like a fraction, yeah, and it's rational. All fractions are rational. Decimals that end at a certain point are rational, as well as repeating decimals are rational, right? And this is the part where you'll see it as subtext right here. Repeating decimals are rational. Thank you. It looks weird now. Oh, there it is again. Now it's gone. Trying to make it erase. Okay. Now we got to put it in 3 times. More work. Okay. So, like, what is 1/3 in decimal form? Who knows? 1/3, yeah?
0.3333.
0.333 repeating. Yeah. So 1/3, 0.333 repeating is rational. So repeating decimals are rational. Wow, it's magical land. Yeah. Okay, so any guesses what irrational would be? Yes.
Numbers that don't end, like
Yeah.
decimals.
Yeah. Decimals that go on with no patterns and they don't end. All right, so those are irrational. What type of numbers have decimals that go on forever with no patterns and don't end? Any guesses? Very good. Square roots. Very good. So square root of 3. Do you know approximately what the square root of 3 is? Any guesses? What times what is 3? Yes?
1.5.
Yeah, 1.5. It's 1.7. So this is actually 1.73 something, 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 on and on and on. Anyone want to do on the calci and tell me?
Oh, it's wait, so
Yes?
there are numbers that just don't have, like they're not
Very good.
they're not whole numbers that
Right, they're not whole numbers. Okay, repeating definition. Irrational numbers are decimal numbers
Okay.
that go on forever and there's no pattern.
Okay.
Like 1/3 we said was 0.33333 repeating, and so that's rational because it has a pattern. Irrational has no pattern, it goes on. Any other number is irrational that you can think of? Yeah?
Pi.
Pi, that's right. Pi. 3.14, da 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 da. Yes?
So irrational has no pattern,
Right.
but rational has.
Right. Like if you have like a rational number is like 0.09090909, that would be rational.
Oh.
But irrational, 0.09, 1, 2, 4, 9, whatever,
So
is irrational.
And that's
Yes.
usually only square roots for
Square roots and pi stuff. Yeah.
so for rational, it could go on forever. Just sort of it's a.
It
pattern.
repeats, exactly. It could go on forever. So rational either goes on forever and repeats, or it ends at a certain point. Okay. And now, so let's put it in blue. So this will be rational and irrational. So now, this is rational and irrational. So you could either be one or the other. That's the idea. You could either be one or the other. And so, if you're irrational, can you be a whole number?
You're what?
If you're irrational number, not an irrational person. If you're an irrational number, can you be a whole number? Your answer was no, that's correct. All right, so let's do a few examples. Okay, I'm going to erase the board. I'm really going to erase the board, don't worry. Okay. Examples. What types of numbers are these? The number 5. Okay, so maybe can we do it in order?
Yeah.
See if we, yeah, starting with
Natural.
natural. Kind of starting, yeah.
Natural, whole.
So there we go. Natural. Everyone together.
Whole.
Like everyone, people are like, what? Whole.
Integer.
Integer. I'm going to do that one, all right? Rational.
What's it?
Yes.
No, how's it rational?
It's rational because it could be like 5.0,
Oh, and then 0.
And that's a decimal.
and it's a decimal, yeah. If you're rational, you're definitely all of these. No, excuse me. If you're natural, you're definitely all these. That's what the point of the chart is. I messed that up. So if you're natural, you're definitely rational. If you're rational, you're not necessarily natural. That's the idea. Any questions about that?
Yeah.
Okay. Any questions? Yes.
No.
What's your question? Like, no, I don't have a question. Okay. All right, so 1.2. I just do this for fun.
The caption.
No, this is what teachers do, right? Teachers are like this. Like, someone's like, wants to say the answer, and the teacher's like waiting for you. Yeah, yeah. And it's like, ugh. Is it annoying?
Yeah.
It's like, here, tell me what it is. What's 1.2?
1.2 is a rational. I don't know.
She doesn't get the joke. Yeah. Raise your hand!
Oh, I get it.
I know, no, okay. You didn't really have to raise your hand, but I was just joking. Okay, yeah, so what's 1.2? Go. What type of number is 1.2?
1.2 is a rational number.
You're asking me or you're telling me? All right, who can tell her whether she's right or not? Yes?
It's a natural and an integer.
Is it natural?
Not natural.
No, it's rational.
What type of numbers are natural?
Whole numbers.
But
Yeah, like 1, 2, 3, 4.
No decimals and no fractions.
This is decimal, so it's
Okay.
not, right?
It's not an integer.
So what is it?
rational.
Rational.
It's rational.
Rational. Anything else?
No.
No.
The natural numbers are always whole numbers. Like they're
If you're natural, look how it works.
right.
Pretend this is like a mountain and this is the top, you know? If you're natural, you're definitely in rational. But if you're rational, you're not necessarily natural. Okay? So let's do a couple others.
Wait, but I don't get how it's rational.
Rational numbers, rational numbers are
1.2.
The decimal
decimals.
doesn't go on
Oh.
forever.
Right. So now what about 1.22 repeating?
It's rational.
Same rational, good. What about -3? -3 is, yes?
Integer,
It's integer.
and that would be rational.
Rational as well, very good.
Can it be a whole number?
Whole numbers start at 0, 1, 2, 3, 4. Okay? And negative numbers are integers. All right, one more. Square root of, oh no, a couple more. 36.
Irrational.
No, it's
Tricked
rational.
ya!
It's a
Oh, it's a
whole
whole number.
That's me
Why
tap
is
dancing.
the integer? Right.
Oh, because I stands for
It's
irrational.
natural whole.
Oh wait, I stands for
Wait, I don't get it.
I just don't like having
It's
stuff in my
natural,
pocket.
integer, and rational.
Oh yeah, I stands for irrational.
Well, why
so.
is -3 rational?
-3 is rational because it's a decimal that ends technically.
So you just said
3.0.
it's
No, why is it
irrational.
What?
Irrational.
Oh no, this is integer rational.
Oh,
But you said Z is an integer.
Oh, yeah. Z is an integer, that's right. Oh! You're right.
You're
God,
confused.
I'm confusing my own self.
Can we
Thank you.
just write irrational?
Yeah, right, irrational. See what I have a problem with
I
symbols.
mean-
It's not
Integer.
irrational. It's integer.
I love when this happens. It's like it's so authentic. Yeah, integer.
Integer.
Right, integer. Yes, yes, yes.
Okay, I don't get how 1.22 repeating is rational.
Rational numbers are decimals that either end or have a pattern. See, this is repeating this bar
So
here.
if it was like 1.23,
1.23 ending,
and
still
rational,
or 1.23 repeating,
that's still rational.
both rational. Yes.
So if it was like 1, 2, 3, 4, 5, 6, 7, 8, 9, just kept
And then-
going.
And then what?
No, just kept going.
And like with no pattern,
That's
Right.
rational.
that's
That's
irrational.
Right, that's what I mean.
Right. Right.
So if it doesn't have a pattern and
If it
keeps
doesn't have a
going,
pattern and
then
keeps going, it's
If
irrational.
it has a pattern and it stops.
If it has a pattern or it
Or-
stops,
or stops.
is rational.
So maybe there's like
Good job.
10,
1.22
11 different
keeps
numbers,
going.
but then it ends. So like 20 different numbers. but
Yeah,
it
so
ends.
like 3.1245698 rational.
Okay.
Right. That's right. How many numbers are between 1 and 2, by the way?
A lot.
10.
10 numbers between 1 and 2?
No.
1.
One number between 1 and 2?
Infinity.
No.
Point
0.2, 1.6.
So how many numbers are between 1 and 2?
We got the
Infinite number of numbers
Why?
between 1 and 2.
Oh, true.
Yeah. 1.1, 1.2, 1.22, 1.222, it goes on and on. Yes?
So the square root of 36 is natural?
Okay, so let's talk about it. What is it?
6.
It's 6, right? So it's natural. What else is it?
Whole,
Whole.
integer, and rational.
Integer, rational.
Yeah, you tricked me there.
Yeah, I did.
How, wait, it's natural because it's a whole number.
What is the square root of 36?
6.
6. So 6 is natural. Now this is the last one.
Wait, but why is it rational? Isn't rational only fractions? And that's
No,
irrational.
because
That's irrational.
irrational.
Right?
So
It's not simple.
rationals aren't only fractions. They're everything that we already talked about, including fractions.
Oh.
That makes sense?
Oh,
So that's irrational, right?
So that's what we'll do. Yeah, so this is irrational.
Yeah.
Okay.
like if it doesn't have a square root or like to reduce.
Right. Usually like the square root stuff are the ones that go on and on with no rhyme or reason. Any other questions? All right, that was great. Okay. So take us out one more right in front of the frame. Thank you, everyone. I will meet you in the cave with the dragon and we'll slay math all year long. Sounds good? Okay.